Hello student, today we are going to discuss one more interesting topic of Laplace transform and also in form of a property of a Laplace transform of a derivative of any function and Laplace transform of a integral of any function if we have a Laplace transform of that particular function. And if time permit, we also discuss about initial value theorem and final value theorem. So, let us discuss about derivative property of a Laplace transform. So, here already we write the theorem. Laplace transform of a derivative. If Laplace transform of f t equal f s, then Laplace transform for f dash t equal sfs minus f0. We may also write this as a Laplace transform of f dash t equal s Laplace transform of ft minus f of 0, because fs is a what? Fs is a Laplace transform of a ft. So, here it must be necessary ft and f dash t both are from the category of a class A function. What is a class A function? A function is said to be a class A function if it's have an exponential order and exponential order as t tends to infinite and either piecewise continuous or continuous from t equals 0 to infinite. So, ft and f dash t both are satisfy these two property. So, these two function must be from the class A function, then we able to prove the Laplace transform of f t equal fs, then Laplace transform of f dash t equal sfs minus f0. So, again I repeat the statement, ft and f dash t both are from the category of a class A function. So, here if both are from the category of a class A function, then it must be necessary there exists a Laplace transform of a ft. So, now by definition of a Laplace transform, Laplace transform of f dash t, Laplace transform of f dash t equal what? 0 to infinite e to power minus st ft dt. Now, we integrate this integration by parts. So, what is the integration of this one? Means integration of e to power minus st is a what? Integration of here f dash t. So, this one is f dash t. So, here what is the integration of f dash t? Integration of f dash t is a ft. So, obviously, here we write e to power minus st and integration of f dash t is a ft. And what is the limit? Limit is a 0 to infinite. And second term is a minus integration from 0 to infinite. Differentiation of a first function, differentiation of a e to power minus st is a what? Differentiation of a e to power minus st with respect to t is a what? Here this become minus s, e to power minus st into minus s. And integration of f dash t is a what? Integration of f dash t is again ft dt. Now, if we put the limit here, upper limit and lower limit, if we put the upper limit, then this become limit t tends to infinite e to power minus st ft, e to power minus st ft. And if we put the lower limit e to power minus st, e to power minus st, f of 0, e to power minus st. Here this become e to power minus st, e to power 0 become 1, f of 0 become what? F of 0 become 0. F of 0 become 0. So, here not f of 0 become 0, here we write what? Here we write e to power minus 0 means e to power 0 into f of 0. We cannot say directly here f of 0 is a 0 because maybe this one have a different value. So, here what is the, if we put the upper limit, limit t tends to infinite e to power minus st ft, and if we put the lower limit, then the e to power minus st become 1 and this become f of 0, and here minus minus become plus 0 to infinite s e to power minus st ft dt, ft dt. Now, since as earlier we say that ft and f dash t both are from the category A function, from the category of a from the category A function. So, if ft is from the category A, then it must have an exponential order as t tends to infinite, then limit t tends to infinite e to power minus ft equal to what? Equal to 0. If this function does not have exponential order, then you cannot say limit t tends to infinite e to power minus ft equal to 0. But ft and f dash t both are in the category of a class A function, so both have a exponential order as t tends to infinite. So, ft have a exponential order as t tends to infinite. So, what is the limit? Limit tends to 0. So, and what is the value of this one? E to power minus 0 become 1 and this become into f0. So, if we write expression in a next phase, so what is the Laplace transform? Laplace transform of f dash t equal 0 minus f of 0 plus s outside 0 to infinite e to power minus st ft dt, ft dt, ft dt. So, now we know that by the definition of a Laplace transform for ft e to power minus st ft dt, 0 to infinite is a what? Laplace transform of a ft. So, here after simplification this become what? This expression become Laplace transform of a f dash t equal s, and this expression become what? Laplace transform of a ft by the definition of a what? By definition of a Laplace transform. So, s Laplace transform of a ft minus f of 0, f of 0. We may also write this one as s, because Laplace transform of a ft is a fs, this one is a given in a theorem. So, sfs minus f0. So, this one is a Laplace transform of a f dash t, f dash t. In a similar manner, we also able to find out Laplace transform for f double dash t. Obviously, f double dash t is also from the category of a class A function. So, in a similar manner, if we try to find out the Laplace transform of f double dash t, then this one equal s square Laplace transform of ft, Laplace transform of ft minus s f of 0 minus f dash 0, f dash 0. Similarly, for the third order derivative, Laplace transform of a third order of a ft, f triple dash t equal s cube Laplace transform of a ft, Laplace transform of a ft minus s square f0 minus s f dash 0 minus f double dash 0. This one is a Laplace transform of a third order of a ft. In a similar manner, if we generalize this concept, Laplace transform for f nth derivative of a ft, fn t equal what? S to power n Laplace transform for ft minus Sn minus 1 f of 0 minus Sn minus 2 f dash 0, and in a similar manner this become Fn, here is third, then second derivative, second, then first derivative, then this become Fn minus 1 0, Fn minus 1 0. So these results can be treated as a formula in order to solve the numerical problem. So, and if we talk about application of this property, if we have a Laplace transform of ft, then we able to find out a Laplace transform of a derivative of a first derivative of a ft, means f dash t, second derivative of a ft, f double dash t, f triple dash t, and similarly nth order derivative of a ft, we able to find out a Laplace transform of a nth order of a ft, nth derivative of a ft. So these formulae, these result can be treated as a formula in order to solve the numerical problem. So now next we are going to solve two numerical example using the property of a derivative of a Laplace transform. So based on a property of a derivatives, here already we write a problem. What is the problem? Problem is a first one is a if Laplace transform of a 2 under root t by f equal 1 upon s to power 3 by 2, then so that Laplace transform of a 1 upon pi t to power 1 by 2 equal 1 upon s to power 1 by 2. And second problem is a if Laplace transform of a t square is a 2 upon s cube, then so that Laplace transform of a t to power 5 is a 120 upon s to power 6. So these two problems are based on a derivative property of a Laplace transform, means if we have a Laplace transform for ft, then we able to find out the Laplace transform for f dash t, f double dash t, and nth derivative of a ft. So if we closely observe this function ft and this function, so this function is a derivative of this function, and here in a second problem, if we have a Laplace transform of a t square, then we try to find out a Laplace transform for t to power 5. Directly we also able to find out a Laplace transform for t to power 5, but here with the help of a Laplace transform for t square, we try to find out a Laplace transform for t to power 5 using the derivative property. So one by one we solve these two problems using the derivative property of a Laplace transform. So first we solve a first problem. If this one is a given, then how we prove that this equal to this. So what is the given? Solution of a first one, solution of a first problem, let ft equal 2 times under root t by pi, under root t by pi. Once we verify, this one is a problem. This one is a problem. This one is a ft. Suppose this one is a ft. Now what is a f dash t? F dash t, derivative of this one is what? 2 times into t to power 1 by 2. So 1 by 2 into t to power 1 by 2 minus 1 upon pi to power 1 by 2. If we simplify, this become t to power minus 1 by 2 upon pi to power 1 by 2. If we simplify more, t to power minus 1 by 2 goes in a denominator, then this become t to power 1 by 2. So we may write pi into t to power 1 by 2. So what is the problem? this one is a given, there is a need to find out a Laplace transform for this one. So, if we assume that this one is a ft, then this one is a what? F dash t. So, indirectly ft is a Laplace transform for ft is a given, and there is a need to find out a Laplace transform of a f dash t. So, here what is the given? Let ft equal 2 under root t by f, and this one is also given, given that Laplace transform of a ft equal Laplace transform of a 2 under root t by phi equal to 1 upon s to power what? 1 upon s to power 3 by 2. This one is a given. Now, we know that now by property of a derivative of a Laplace transform, property of derivative of Laplace transform for f dash t equal, and here we assume that Laplace transform of ft equal what? Ft equal fs. So, Laplace transform for f dash t equal s fs minus f of 0. So, if ft equal 2 under root t by f, then what is the value of f0? If we calculate here the value of f0 is a what? f0 equal, if we put the value of a t equal to 0, the f0 equal to 0. So, here we put the value of fs and the value of f0, then we are able to find out the Laplace transform for f dash t, and f dash t is a what? F dash t is a 1 upon pi t to power 1 by 2. So, we put the value of f dash t, value of f0 and value of fs. From these three expressions, if we denote this one is a first, this one is a second one, and this one is a third one, we put the values of f dash t, fs and f0 from the expression first, second and third, then we get the required result. So, after putting the values, Laplace transform of 1 upon pi t to power 1 by 2 equal s into fs. Fs is a what? Fs is a 1 upon s to power 3 by 2. 1 upon s to power 3 by 2 minus f0, f0 be the 0. So, now after simplification, this become 1 upon s to power 3 by 2, and sfs this become what? Minus 1. So, this become 1 upon s to power 1 by 2. 1 upon s to power 1 by 2. So, Laplace transform of 1 upon pi t to power 1 by 2 equal 1 upon s to power 1 by 2. So, I think this one is a result. So, we are able to prove this one. So, this one is a proved. Now, in order to solve a second problem, what is the second problem? Second problem is if we have a Laplace transform for t square, then with the help of this means a Laplace transform for t square, find the Laplace transform for t to power 5. So, now how we solve a second problem? Second problem, what is a given? Given is a Laplace transform of a t square equal 2 upon s cube. 2 upon s cube. So, this one is a given. Laplace transform for t square, this one is a given. Given Laplace transform for t square, there is a need to find out a Laplace or prove that, then so that Laplace transform for t to power 5 equal 120 upon s to power 6. So, in order to solve this problem, how we find the solution? Let ft equal t to power 5. We assume that ft equal t to power 5. Then what is the f dash t? First order derivative f dash t equal 5 into t to power 4. What is the second order derivative? F double dash t equal 20 into t to power 3. And what is the third order derivative? F triple dash t equal 60 t square. 60 t square. Now, we have a t to power 5 and we have a t square, and we have a Laplace transform of a t square. So, by the property of a derivative of a Laplace transform, third order derivative of a ft, using the property of a derivative of a Laplace transform, third order derivative of a ft become what? Laplace transform of a f triple dash t become s cube Laplace transform for ft minus s square f of 0 minus s f dash 0 minus f double dash 0. So, here what is the unknown? Unknown is a Laplace transform for t to power 5. What is the known? Laplace transform for f triple dash t means Laplace transform of 60 into t square, f of 0, f dash 0 and f double dash 0. So, there is a need to value of a the value of a f of 0, f dash 0 and f double dash 0. So, from here if we put t equal to 0, then we find the value of f of 0 equal to 0, and what is the value of f dash 0? F dash 0 equal to 0, and what is the value of f double dash 0? F double dash 0 is again 0, because if t equal to 0, then f0, f dash 0 and f double dash 0 equal to 0. So, we put all these values with f triple dash t equal to 16 t square and Laplace transform for t square equal to 2 upon s cube. So, after putting the values here, we put a Laplace transform for f triple dash t means a Laplace transform for 60 t square equal s cube. Laplace transform for ft is a Laplace transform for t to power 5. Laplace transform for t to power 5 minus s square, and f of 0 is a what? F of 0 is a 0 minus s, f dash 0 is a 0 minus f double dash 0 is a 0. F double dash 0 is a 0. So, after simplification, this term becomes 0, this term becomes 0, this term becomes 0. So, after simplification, what will happen? Laplace transform for 60 t square equal to Laplace transform for t to power 5. Laplace transform for t to power 5. S cube Laplace transform for t to power 5. S cube Laplace transform for t to power 5. So, using the linearity property of a Laplace transform, this expression become 60 Laplace transform for t square equal s cube Laplace transform for t to power 5, and Laplace transform for t square is already given. So, here we write 60 into 2 upon s cube. This one is a given. Laplace transform for t square is a given. So, this one equal s cube Laplace transform for t to power 5. Laplace transform for t to power 5. After simplification, s cube become in a left hand side. Then after simplification, Laplace transform for t to power 5 become 120 upon s to power 6. S to power 6. So, this one is a result that required to prove. So, this one is a proof. This one is approved. This one is approved. So, what is the summary? Summary is if we have a Laplace transform for ft and Laplace transform for ft, then we able to find out a Laplace transform for f dash t, f double dash t, f triple dash t, and nth derivative of a ft, nth derivative of a ft. So here we solve two numerical example using the property of a derivative of a Laplace transform.